Welcome to the demonstration of realizing literate programming by inferring implementation from multiple textual description of method invocation and context. In this plugin, we use shortcut key to get the result from multiple textual description of methods. Now we are considering for example. In example 1, we wrote println method name. We can input by 3 parts: method, text description, variables, and terms. In here, we only write println. We can see that MICPlugin will make a unique alias as method invocation in your editor. This allows the AST parser to extract source tokens with error recovery. All information about the input query is embedded into a dictionary with the key as the alias name. Then we will translate this result. The result shows the popular printf system out class, with accept a parameter as string. We can see the detailed translated result. Second example. In this example, we will write a list of textual description. The expected result can be found in the Nexus Android project. Now we translate the result. We can see that, different from the first example, now print and println will be translated to another implementation. If we provide a printwriter variable, the output of translation will automatically update the final code. Now we add printwriter argument and we see the translated result is close to the expected result. Third example, we input char and other information. We see the result like this. In the result, we show that the generated expression is a method invocations that required 3 variables, a string and 2 integers. Now, if you want to use plus operator instead of minus, you can add it in the term section and see the result. Now the result chand. Fourth example. Now, in the fourth example, we switch the input mode, which we allow users to input in natural language. In this scenario, we input 2 textual input queries related to the binary search. Now we see the details of each query. From the input query, the list of method names, variables, and suggested terms are automatically extracted. There are ambiguous entity, the array, which we use rule-based approach to extract and map it to a long array. We can update the method name if we want. In here, I will select the second method name, binary search. Now I have the tokens as the translated result of this case is an APIs of Java, util, arrays, and the final code is correct. In this work, we relied on the ability of learning from the incomplete representation to complete representation of code in practical Java GitHub project. In the the expression ID can be represented by the code without local variables, required parameters types to adapt to the expression code, and the set of import APIs to editor. The list of expression ID is learned from the representation of 2.8 million's method invocation on GitHub. Input. Users can input by 3 parts, or input by natural language. If users input by natural language, the query will be pre-processed to have 3 parts automatically like the first mode. The method name will be selected as the most similar method name from the corpus. In overall, might get the code by 3 layers. 1. Combine information about textual descriptions and surrounding code to have source tokens. 2. Applying method info to code to get target tokens. 3. Inferring final code from target tokens. There are 2 models of translation, the compact model and embed info model. The machine translation model will get information from source as method name and context and target as its respected expression ID and context by language model and translation model in SMT. The overall of translation is provided as follows by 3 layers. We combined 3 techniques: textual similarity search, machine translation, and program analysis as 3 layers for inference. Let's see the example 2. After aliasing, the code will be converted to a list of source tokens. Each method name and context for each query. Then will be translated to a list of target tokens, which contains expression its. Then using matching types of required params for each expression id and surrounding variables, we will have the final translated result.